You asked you need examples, right? So what I will do, I will create a repository. Okay, let me let me update our classroom examples also here. You have another examples link. There you have all generic examples, easy examples for you to practice right ahead before our session. During session or during after session, if you want to practice something, let's use this. Yeah, we have multiple here. Let me add them. Machine foot. Right click, go to path. Okay. Each one let me compress as a zip file. 1, 2, 3, 4, 6. In video you can see which example we did and the same one you can pick up. Yeah. So let me put them here. Okay. 8 zip files got uploaded. Commit. So almost, yeah. So this is the link. You can download there. Okay, you all can access this link and just download each project from here as well. So when you want to download, right, just click on that file, click the download option. Okay, it downloads the zip file. Just keep it into your local and test. Okay, Spring Framework, Spring Context Support, Transactions, JDBC, ORM, OXM, Web MVC, Portlets. Okay, I just wanted to do Maven based examples. Maybe from next session we will do it. Okay, instead we wait. Yeah. So from dependency injection, we understand that, right? So before dependency injection, right, before Spring itself, how people used to do or get these dependencies using dependency lookup concept. People usually used to read the data. If they want anything, they used to do lookup for it. They used to read it from data sources or from file system somewhere or from the network. When you read something, it will become a tightly coupled code. When you read something, when you read something for that reading purpose or to get something into your code, if you write here the statements, right, your statements will become tightly coupled. Dependency lookup code always will become tightly coupled. Again, it depends how you design the system, but still your code is like a dependency lookup code is like tightly coupled code. Whereas in dependency injection, IOC is doing what? It says you don't do any lookup code. You don't need to read anything. During building of your object, DAO object, you need not to read anything. During your object creation of DAO or during your method executions, as a developer, if you need any dependencies, as a developer, if you need any inputs to your class, file or you say collections or you say simple properties or any other object as a property you want, you don't need to look up for it. You don't need to create or hard code for it. You configure the parameters, that's it. You just configure the parameters which you want in your class instance level and put a setter methods or constructors for your properties. Then IOC will start injecting them. IOC will read that properties which are you configured in XML file. IOC will read when you start IOC container, right? It will read your XML file first. From your XML file, it will read all your properties, and from the XML configuration, it will understand okay which property need to go to which variable, right? All that configurations we do in XML, so easily it will understand where each parameter need to be passed. So based on your instructions only given in XML, it will do that. So that advantage here, when you do something via XML files, we call them deployment descriptor files. So when you use XML file or some properties files to pass your data, they will allow you to flexibly, they will allow you to change the data at any time. You go and change the data here. It should not, it should not impact your application. at least for compilation time. So if you properly implement the dependency injection concept for your application, right, your application should never give any compilation errors when you remove the dependencies key, whichever dependencies you have. When you remove that old dependencies, when you add new dependencies, still your compiler should not give any errors to this DO class compilation. That is what clearly loosely coupled classes means. When you write multiple classes in your application, when you remove a class, if other classes started showing the error messages, right, that means that classes are tightly coupled. For example, tightly coupled code, let me give a simple again core example here, a core example, and see what compiler will do if I create and delete them. A simple Java project, a core project, tightly coupled compiler errors. So compiler errors we can see during tightly coupled. So if I write a class here, beans. So here I have a class employee service. Show pay details. So uh, employee want to see his pay slip. So consider this method is like pay details, and employee have one more method show attendance. We want to see his pay details and his attendance. So to see pay details, he wants one object, payroll object or payment object. So he's hard coding for it, payment, and let's create payment class. Attendance class. Let's create it. Now employee service is having two dependencies, payment and attendance objects. So instead I using best design practices, I hard coded that objects and created this application. In future, I observed that existing attendance object is not properly designed or that is not suitable for the current requirements. During the attendance earlier, I used to give employee name and his in time out time only, private int employee ID and private string employee name, in time out time only I have. The daily login details I have. And I feel that I need some extra details and this class itself is not helpful. I thought of creating a new class. So immediately I came into conclusion that let me delete this class. As soon as I delete the class, here you can observe employee service is giving errors here, attendance. Why so? Because that class is not available. Okay, if that is not available, why you are crying here with errors? It is saying I need this class. Compiler will not work if you put some class which is not there. So how I can avoid this problem here? Means in core Java itself we have runtime polymorphism concept, and there itself we have one more concept, inheritance. So if you can club that concepts together and if you apply it here, it will create beauty. How? That is what we will see it in dependency injection, right? Instead you creating that object here, if you can able to inject the object instead of injecting it directly into this class. Let me give an example. Instead designing in such a way hard-coded practice, what you could have done is during your application creation, let's say this is a car class, like employee service. I have a car class. My car need tires. Okay, car class is having tires dependency, right? So before going to put tire here, if somebody or if you design a tire interface first, tire or interface tire, I tire means interface tire. In this interface tire, usually interfaces will have abstract methods or default or static methods. Interface tire size and pattern. I came to know that patterns will change the comfort in the car. So each tire is having a different pattern that will change the comfort, and the range up to how many kilometers the tires can run. So this is just interface, right? Interface will not have any implementations. During your system design, if you have any DO class, service class, or a controller class, anything, consider this class is like a controller or your service or a DO, anything. Can be anything. Just imagine, right? Your car needs a tire, not a tire, four tires it needs. So while injecting the four tires here or while injecting at least a tire here, if you hard code a tire class, if I hard code a tire class here, reference T with a setter method, still your code, you are using dependency injection via setter method and trying to injecting tire object here. Still, this approach is good. Your setter is good. It is in green zone. But whatever reference you have put it here, this is in red zone. This will create tightly coupled structure between your car and tire. So to bring it into green zone, what you need to do instead of creating a class reference directly here, instead of creating a class reference directly here, keep it a interface reference. Right? Interface will not have any implementations. Okay, if no implementation for interface, what I should inject here into this iTire? First, do this code in such a way that don't put any direct class dependencies here. If you put that, your code will be in a red zone. So instead, you put it a interface reference here. Now I need a class. I don't want interface here. To my car, I need a class. Don't you want interface? So you need to change your thought process here. So while writing code, we fatafat write class names here and setter methods here. I don't want to go with interface. Why don't you go? If you see the other industries apart from software, automobile, Or if you see the mobile phones, the gadgets, right? Automobile industry, cars. I mean, the machines got, or you know, at least if you see the history, the four wheel machines came very long back, early in 1800s or 1700s. Even kings also used to use with horse, what we call, I don't know the name. They used to ride four wheel, radhas, right? So during that time itself, they used to fit wheels. If the wheel got damaged, they used to able to remove the old wheel, and they can able to add a new wheel. Let me see the history of a wheel. 4th millennium BC, almost 1600 years before it. Are they saying 4th millennium BC means when in the Iraq they found these wheels. So there, it's almost thousands and thousands years before itself. Whoever architected the four wheel, uh, you know, machines or two wheel machines, they introduced concept of interfaces. How, if you observe wheels, you can able to remove and fit the new wheels. They will give one, chassis. To that chassis we can able to easily fix the wheel. If it gets damaged, we can remove it and you can add new wheel. Instead, if they should have hard coded it, which means if they have tightly coupled, with a tightly coupled relationship, if they fitted the wheels, if one wheel got damaged, that damages the entire machine itself. So instead damaging the entire machine, what they introduced an interface. Their interface means an option to place, like a SIM card, right? SIM card you are inserting via SIM slot, or your memory card inserting whenever you want to remove that SIM and add new SIM. How you use this slot here? SIM slot is a interface for you. This SIM slot is a interface for you, so you can put any SIM there. Same way, this interface is a, just a minute. Just a minute, guys. Just a minute. Just a minute. So instead, yeah. So instead having a direct tightly coupled relation here with your phone, how you have SIM slot here. Same way your application also need to have a slot for each dependency. How you can provide slots technically in Java, slots you can provide via interfaces. Interfaces given for that purpose only. Interfaces given for that purpose only. The interface definition itself is, we always thinking that interfaces needs abstract methods, only abstract methods we put there and implement. But why, what is the reason behind it? They given for interfaces purpose. Like you can create slots using interfaces. Same way in Java also you can create slots using these interfaces. Then I have a slot. Which slot it is? Tier type slot. So here I have which type slots these are. Two are SIM type, and one is like dual SIM slot. Yeah. So this is how it looks like. Excuse me. Oh, Amazon selling this as well. So now if you see here, here we can place only the memory cards here. And here SIM slots given to place SIM cards here. So we can place SIM 1 here, SIM 2 here, and in case if you want to remove that SIMs and add new SIMs you can place here. So such a way interface given. This is a interface. SIM slots interface. Same way during your application design, why you are not using interfaces? Interfaces given in OOPS concepts, we start with interfaces and classes then. So you learned about interfaces, why you are not using that interfaces here? If you use interface, your application will become loosely coupled, like how your phone is loosely coupled with SIM card and memory card options, right? Same way. And you may put question, don't we have even single line in our application? Yes, you can write hard coded code sometimes. In some places you may put it, but that is not a good or great practice. If you want to follow good practice, right, you need to do your system design in such a way using interfaces. Like in, you know, 2000, 3000 years before itself, people started thinking about it. As a programmer, we need to adopt the same. You need to design your system in such a way it should give flexibility to you to remove anything at any time and to add new part as part of it. All your classes, if you think like parts for your application, easily you should able to remove any part and you should able to place new part as part of it, in simple words. So how I can get a object here? Okay, will my IOC create interface object? Does it have any capability to do that? Means no, nobody can create interface objects, right? So here in XML file, we configure car class. Into car class we need to inject interface. Car class bean I have, there I need to call my property tag, setter method I should call, and I should pass here which object? iTire type object, not iTire object, iTire type object. So iTire type object only I should pass here. Interface type. iTire is a interface tire. Interface tire object I need to pass here. How is this possible? Can I able to pass interface object from here? Can I create interface object at least? No. Then is there any way to do that? Yes. Generally, interface is given to make sure you follow this rule. Why this interface is given? Tell me why this interface is given in a phone. They given this interface to make sure. Just they given interfaces to make sure, right? While designing phones, the government of India or Troy, right? Telephone Regulatory Authority, or a worldwide forum if they have, because phones everywhere using and everybody designing them. So to avoid the problems between whoever providing sims, right, sim providers and phone designers, to avoid the problems between them, everybody will come into the conclusion that we need this size. So all phones need to designed with same slots, and all sims also need to designed with same sizes. Everybody will publish it and ask everybody should follow it to avoid the problems and to create more convenience. Like USB device, you are using pen drives. So you go anywhere in the world, they use same size pen drives. I mean same size in the sense the slot, pen drive slot is same. USB slot size is same. Go anywhere, same size. But your laptop chargers and their pin sizes might change. It's their choice, but the USB sizes are same. Everybody should follow the same sizes. So here in interface, via tire interface, what I am saying, follow these rules. Yes, follow the size or pattern range. You should follow them, and you need to implement a class here. You need to implement a class out of it. You know how to implement it using simple. Now you design here tire by implementing iType. Now here you implement all these three methods. Now tire is ready. So while designing car will design with chassis, and they will after car designing, right, they will give that choices without tires, and there actually people will start fitting the tires and deliver it, right. While getting your new car, you will get with the tires only, so they will fit and deliver it to you. So later when you feel that I don't want these tires, I want to install new tires, you need not to hesitate. You can remove the old tires and you can insert new tires. They give an interface for you there, option given to you. So they are not restricting you to remove old tire and put the new tire there. You can do that. So here I need to pass an interface object. Interface never give you an object, but interface implementation can give you an object. So this is suitable for this interface, which means in Java we can do this. Parent class reference is equal to new child class object. Is it not possible in Java? Parent reference equal to new child. It is possible in Java. In Java, it is possible. This is what the runtime polymorphism is. This is what runtime polymorphism says. Use parent references and pass child objects. So, and these parents use interfaces, not a simple class, use interface. So, you'll get so many benefits out of it. So, now into iTire reference, right? Into iTire reference, I can pass tire object. Is it possible or not? Yes, it is possible. This is the legal approach and right approach. Not only legal, this is the right way of doing good coding. Java is enabled you to design your application lightweight, loosely coupled. Then why you are hard coding and making it tightly coupled? Core Java itself giving you all that features to you. So if you follow them properly, your application, at least it can be some up to some extent level, it is loosely coupled. At least if you design car, Yeah, if it's your wish to allow them to change the engine or not, that is your choice. But at least you should allow users to change the tires because they will get damaged soon. So in such all places you can use interface implementation model. Now it is possible to you to pass this object here. This is possible to pass this object here. Now your application car class and tire class will become loosely coupled. So as I said before, right? I have a interface reference here. I have an interface reference here. So generally you will not disturb interface. So tires only you wanted to remove. So for my class, in my application, car is one class, I type is one interface, tire is one class I have. So I want to discard this class. I want to delete it. I want to delete it. So as soon as I delete this file, will your car class show any error? No, because you are not at all using that tire reference directly here. Instead of tire reference, you are using iTire. Means when you go to workshop and when you ask them to remove a wheel, will they say I can't? No, they should. They should able to remove the old wheel. As part place of old wheel, they should able to add a new wheel there, new tire there. Still, your car will not say don't remove it. It will allow you because car is not having a tightly coupled dependency tire here. Instead, we have I tire type we have here. That is a interface. So this is how you can make your application classes loosely coupled by mentioning interface type here. You are allowing your car class to accept data which is coming from XML, right? To accept data which is coming from XML, the implementation objects, and that is doing achieving via IOC. Via IOC, you are achieving it. Via IOC containers, you are achieving it. Of course, containers will create objects and they can do the dependency injection also. Whatever you mentioned here, the same way it will inject the object. Whatever object you have given, the same object, it will pass it into your tire reference. So this is how you can make your application classes loosely coupled rather than tightly coupled. Which means while designing your classes, right? While designing your classes, controller class you need to design in such a way in your controller class, right? When you implement any controller class, and controller classes need to talk with service classes. Service classes need to talk with the DAO classes. Let me minimize them. Controllers, service, DOs. Usually three classes we write. Usually three classes we write. So during design of controllers or during design of your service classes or writing while writing service classes or while writing DO classes. If you need any dependencies, right? Let's create interfaces for the dependencies and implement your dependencies from interfaces only. What I mean is, if controller class needs a service dependency, first create iService key, iService reference, which means a interface. Create an interface first. So here before this service class itself, create a service interface first. And from this interface, you implement your class. So when you use IOC between, right, controller and service, here we use dependency injection. Who do that? Dependency injection will done by your IOC. So while IOC injecting it, right, your IOC will pick up this class only. IOC will pick up this class only. IOC will pick up your class only. Your class only it will pick up. And using this dependency injection, it will inject it into interface reference. So your controller class and service classes will become loosely coupled. Same way, when your service class requires a DAO dependency, instead you use dependency of DAO directly here, use DAO interface dependency, and rather than creating DAO class directly, you create a DAO interface first. Is it a big deal creating interface and implementing? No. You must have played with it many times. Create an interface and implement it. Now, when you use IOC for dependency injection, when you use IOC here for dependency injection, comfortably it can create your object and inject into interface. This DAO object IOC can create as soon as you configure it in XML, right? It create that object, and whatever that object you created via dependency injection, it will supply here. Now, if you see these three layers, right? Three layers are like loosely coupled layers. Controller will never directly depend on any service class. Service will never depend on any DAO class. What is the advantage or faida here? So the advantage is in future, if you observed that JDBC code is there, and using JDBC you implemented this class. I wanted to discard JDBC. It is outdated. Some outdated technology still there in my application. I want to remove it. I want to remove it. Outdated code is there as part of my DAO. So I want to discard the old DAO class. Let's do it. Delete your old class. And as part of new DAO class, I want to put Hibernate. A new technology I want to put there. Put it. Still you remove your old DAO and add new DAO. Your service class never give you any compilation error. If you ask me a question, I will delete that class and I will run application and I'll try to insert data. Will it insert? No, obviously. You remove all tires and try to drive your car. It go nowhere. Same way. So you should have a flexibility when something is damaged. Usually we will not get any damages in our application side. But we may need some upgradations here. Along with the industry, technologies also need to be upgraded. So the old technologies are putting lot of efforts to me. Every time when I need a small change, I'm approaching a developer. He's taking 10 days to do that change. So I'm investing a lot on it. If I go with a new technology, I heard from my friends that if you use new technology, Hibernate, that will make or allow changes or make changes simply on database with very less efforts in one day. Then I thought of the same and I'll ask my developer team, hey man, remove the DAOs which are with JDBC and add Hibernate as part of it. When I say that, if you try to remove old classes, that old classes references, if you have used in many places, that all places it will raise the error. And the people scratch heads how to remove that classes and add the new changes there. Instead, Instead, to make your application classes lightweight and loosely coupled, if you implement this interface implementation model, it will give you flexibility to remove the old API here and add new API. Okay. So this is what dependency injection is all for. They given dependency injection concept they given. Using that concept, you can inject directly DAO object into DAO reference, service object into service reference. It will help you, but that is not the good design. Even if you do that, your application is like a application, or your thought process is like a 2000 years before thought process, like before 4000 BC thought process. Okay, I never say don't use it. Use it wherever you want, the hard-coded parameters, but try to make as much as possible lightweight application. It will give lot of flexibility, maintainability. If you are not into the development right yet, so once you get a job and once you joined there into a team, and once you start interaction with the clients usually says please make application like a easy maintainable, right? During designs or during their calls they will say to us, try to make application easy maintainable. And even your technical lead or architect will always used to guide you, saying that don't use hard coded, try to make it a static variable, or try to keep it in XML file, or try to keep it in properties file, so that in future when you want to, when client wants changes, when he asks us, we go there and directly do the changes, and that will take less efforts. In such a way you need to design your system. Your system should take less efforts when maintenance changes comes in. Instead you taking 1 hour or 2 hours, if you take 10 days or 20 days, client will not get any much benefit out of it. He will start giving examples of the same. Why you people are not thinking like at least 400 BC people. Okay. So this is how we do dependency injection. If you want to give me an example, yeah, remember this car example, or you may do it like a phone and sim examples also. In place of car, you create a phone, and in place of iTire, you create iSIM. From iSIM, you implement a GeoSIM, and using XML, and phone, in your phone class, put here iSIM interface and inject the GeoSIM into it. Another example I'm telling you, okay? But for real time, remember this. For real time, remember this. We never going to write car class or sim classes. We write always controller service DAOs. Same you should apply here. Controller, if you consider like a car, if service is like a tire, put I tire reference here. Means I service reference and inject service. Again, if you consider like service is like a car, right? And DAO is like a tire. Instead of tire dependency, put I tire dependency here. So that this class to this class, the two classes will become loosely coupled, and this class to this class also will become loosely coupled. So that your entire application is loosely coupled. Clear so far? Yeah. Let me give an example for it. Let me give an example for it. Okay. Creating a simple project. Okay. IOC with loosely coupled architecture. We usually call this is as a runtime polymorphism. Runtime polymorphism in Java. Finish it. Configure. From Monday session, I'll try to use Maven. Okay. So you never see, right? For now generation, you people never see these jar files directly. We used to code, in olden days, we used to download jars and we used to add them into class path. Such a way we used to design it. Just Maven is now sufficient. Maven will download these jar files for you. You need not to go to build path and add them. At least you can avoid that step. Now here, let me write a class. I'll just give you a car and a tire example only. So easily you can remember. In MVC examples, you can recall this example and apply that on MVC, controller service DAOs. Okay. So let me create a beans package. I'll create a car here, and car needs a tire. Before tire, I'll put interface. I tire. Okay. So name of the tire, size of the tire. These two are matter, and pattern also. I wait string pattern. Acha. Interface will have always what? Public methods. Now in car I need that tire dependency, but before that let's implement tire also. Apollo tire, Apollo, Seat, Continental, many providers, MRF. So let's say I have Apollo tire here, implement it from iTire interface. Apollo tire. Implement three methods here. Tire name, pattern, size. Implement three methods here. Apollo tire, pattern, three layer pattern. Size is 16-inch size. Now in my car class, when I want to drive, public void drive. This drive wants to use the car class wheels. So I need, yeah, tire class wheels, tire class it needs here. So I'll put iTire dependency here with the setter method, set iTire. iTire is an interface, nothing in it, just abstract methods. Still your car class using this dependency only. So using this dependency, we can call iTire dot system dot out dot println provider name, tire provider name. You can see here iTire dot name, tire size, tire pattern. Now I have car class. Car class is having an interface dependency. Now let me inject implementation object in it. Go to your string XML file, pin ID. You can't create here, right? In string XML file, you can't create interface objects. So let me create a tire object. Class name is equal to beings dot. What is the tire name? Apollo tire. Cool. Now you can pass that Apollo tire into car class ID equal to car class name beings dot car class. Car class is having one setter method. The dependency type is iTag. So here you use property call iTag setter method. Into that setter method, you can pass this object. Not only string names or integer numbers, you can pass objects also here. You can pass this ID also here. This ID reference you can pass here, so that Apollo object whichever is created, that object is injecting into your iTire method. So will it accept it or not? This iTire method is having iTire interface. Will Java allow implementation class object which is implemented from iTire? Will allow that object to pass? Yes. This is not the greatness of Spring. This is greatness of your Java. Spring is utilized all its benefits properly, right? If you see on high level, who allowing to achieve all this? Your core Java only. So the Java itself is allowing you to do. Okay. So your Java itself is allowing here. So in Java, it is possible that into interface references we can pass implementation objects. So the same thing that we are doing here. This object we are passing it into interface reference. Now let me have a test class here and run it. Let me run my car class. Application context dot get bean of, I'll get a car object, or you can give car class also, car dot class or id. If you give class, I feel it's comfortable. Car object you get here, c dot drive bus. Now let me run it into debug mode and show you. Okay. So car object is created, no default constructor with the SOP written, so you can't see it here. Otherwise your object is created, you can see here. So car object is created, and inside car what you have? Car object created with I tire. Into I tire reference what it have? Apollo tire. I tire is equal to Apollo tire. So now when I click drive method, when your statement goes here, see what happens. Now it came here to drive method. Now drive method is using interface reference dot name. Usually interface dot name, if you see, no thing here, nothing. But usually what it will execute when you call, when you call this interface dot name, whatever implementation object you have given, that object it will utilize. So tire name Apollo tire, size 16, 3-layer pattern. That's it. In future, if you don't want to go with the Apollo, let's say I used it, I feel bored, so I want to shift to new tires. You can implement a new tire here. Yokohama tire, Japanese tire brand it is. I tire. Now let's implement that tire as well. So when you go to workshop and say, my Apollo tires got almost, their life is gone, install new tires. Then I will say, okay, let me remove the old tire, fix the new tire. So now 4-layer pattern I taken, you know, it depends on size. Let's say if you change your wheel size, you can change the tire size also. 17-inch alloy wheels I want to use. So I shifted to 17 inches. Now I have a new tire. How I can inject that new tire into car? And can I discard the old class which is not using? Of course. If you want to remove Apollo, just delete it. See, is it giving any error? Your car is having dependency, but still it is not giving any error because they are loosely coupled. And as soon as you want to pass this Yokohama, you instead of creating Apollo tire, create Yokohama tire here. That's it. Run it. Now onwards it is using Yokohama tire here. So now your car class became loosely coupled with the tire. Of course it should be, right. Yeah. So your application classes also need to be designed in such a way. In such a way you need to design them. Your thought process also need to be in a same way. Okay. So use interface implementation model for dependency injection. This is applicable for secondary types only. Okay, don't worry. This is applicable for secondary types only, which means classes. If you have somewhere strings, numbers, they are fine. Okay, they are fine. Strings, numbers easily you can change from XML file. They never, cry. Secondary types, when you remove the old classes, they will definitely show the error. So instead of having classes dependencies, keep interface dependencies. Follow this model. Okay, yeah, that's it. More about dependency injection we will talk in Monday session. Okay, various types of dependencies. If you guys curious to practice, go to go to our existing go to our existing examples and have a look into it. Are you guys clear? Yes. Yeah. So that's it for today. So you guys can go off. Have a nice weekend. Yeah. Interface. Of course, inheritance means getting parent properties into child. Echohoma is a child for this interface. This interface is not having anything, like a poor father giving nothing to child. Getting? So he have some desires, he has some thoughts. He want to play cricket, but he didn't because of his, situation. He want to buy a car, but he didn't. He want to buy a home, he didn't. But he have all the desires. When child heard about it, he wanted to implement them. So he studied well. He joined a good job. He brought a home, car, everything. Okay, that is what inheritance is. Okay, so inheritance can be happen in two ways: via interface to implementation, or class to class, or interface to interface. Okay, yeah. Any questions? So that is only the inheritance concept is, and this is the dependency injection concept. This is inheritance concept. If you want me to write, I'll write here inheritance concept, and here this is the dependency injection concept, DI concept. Okay, dependency injection providing me more comfort, and Java itself is allowing me to create interface implementation model. So combining both is doing wonders, right? Using this runtime polymorphism with dependency injection creates loosely coupled applications. That's it. Any questions? Anything? Don't feel is it silly or is it big or small? Anything you should ask if you have doubt. Okay. Yeah. That's it, guys. Yeah. Huh. Let me put it right away. Mm, all examples here. Let me go back to repo, add file, upload file. Just a minute. RTP. This example, today's session is very, very, very important. Okay. So just go through this example. Even same runtime polymorphism example you can see in the blog also. Okay, there may be a different kind of example might have given, but this is the one that you need to practice. Okay, yeah, upload it. Later we will apply the same for MVC applications. Okay, so there you will not surprise why I am creating interfaces and implementations. Yeah, that's it, guys.